All right, so let's talk about quadratics for a little bit before we start answering these questions. So, just like in general, a quadratic has a very symmetrical shape about it. Let's say I put my quadratic here. Doesn't matter too much. It has a very symmetrical shape about it. That means that there is, she keeps talking about a line of symmetry. So it's always a vertical line of symmetry. Now, in geometry, even, we've talked about a vertical line versus a horizontal line. And I tried to share with y'all Hoy Vux. Well, if it's a vertical line, then it's going to be an x equals equation. So let's get what that x equals equation is. And now let's just make up some numbers here. It doesn't really matter what the numbers are. For the purposes of just, this is a rough sketch, I'm going to use the two x-intercepts. But it wouldn't really matter. The point is going to be the same. So I'm making up numbers here, but let's say that this is the point 1, 0. And this is the point -9, 0. So what you would know is that the distance from here to here would be the same as the distance from here to here. So if you could count this, which we could, it'd be easier if you had an actual coordinate plane. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, if we could count this, this would be a distance of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that total distance is 10. So that means halfway would be where that line of symmetry, and that's going to be 5. If this is 5, then this is also 5. So I didn't draw this perfectly to scale, but hopefully you can see my point is that after we know the total distance, then you can take half of that, and then you would know where that line of symmetry is. So in this case, that would be at, so taking -9 and counting 5 over, that's -8, -7, -6, -5, -4. So sorry, I didn't draw this perfectly to scale, but that would be at -4. So this, oops, I meant yellow. This would be at -4. -4 comma 0 is that point. And of course, the vertical line is x equals, and then you just look at that point right there. X equals -4. Okay, so maybe that will answer. Let's move all that to the side. Maybe that'll help answer this one. So if you can see that there's a distance from -6 to 0, there's a distance of 3. So if you count 3 over, let me zoom in a bit. If you count 3 over, then you go 1, 2, 3. This would be where your line would be. Okay, and that x value right there you can see is x equals -3. So it is true that that's also going to be, I shouldn't do yellow, that's quite hard to see. That's x equals -3. That is going to be true, that it's also going to give you the x value of the vertex. Okay, in this next question, it says if the maximum value, so that's the vertex. So the vertex is either a maximum. In this case, it's a maximum because you have that upward, upside down U shape. So let's just talk about a few more things. So if you have this shape that is in your current problem, then you have a maximum. Now remember, we've already said maximum. We've already said that the maximum x value is -3. Now the problem is telling you if the maximum value of the quadratic that goes through the point is +2, so we know that it is an x comma y point. We know in this problem it's -3, and then it told us in that reading, go back and read it, it told you that the maximum height is 2. Now it didn't use the word height, but when it's talking about maximum, there's no maximum as far as x goes, because x is either, left, it's right. There's no maximum. It goes left forever, it goes right forever, but it has a maximum height of 2. Whereas this problem over here, if we take this back, and I didn't draw this to scale or anything, but this would be an example that I would have to say, where's the minimum? If I told you the minimum is at, let's just make up a number of -3, then I could tell you that this vertex, so -3, I'll use white again. Oops. 1, 2, 3. Then this vertex would be at, the x value is -4. The y value is -3. Again, I just made that up, similar to how they just made it up on, on this problem. Pull that back. On this problem, they just made it up and gave you 2. Okay, so what is the equation for the quadratic equation in vertex form and standard form? So far, remember that your vertex is your h and your k, and you've got this written down. So let's take that. So y equals a x minus h squared plus k, and the vertex was at -3, 2. So we can plug in -3. Is that right? Yeah. So we can plug in -3, -3 right here for h, and we'll plug in 2 for k. So we've got y equals a x minus, see that minus sign right there? I'm just rewriting that minus sign. Now my h that I'm going to plug in is going to be -3, so something's going to happen here, right? -3 squared plus the k that I'm plugging in is 2. So hopefully you're pretty good with this. Minus negative, that'll actually make a plus. I'm just going to go ahead and change that to a plus. 2 negatives make a positive. So that's now x plus 3. Again, that happened because there was a minus sign and then I plugged in a minus sign. So the 2 minus signs made a plus. Now we were also told a point. Based on the graph, we were told the point, either one of those points would work. You were given the point -6. Is it -5? Yeah. -6, -5, or you were told the point 0, -5. Now, technically, you could use either one of these, but just knowing math, I mean, it's going to be easier to plug in a 0 point, because when you plug in 0, then it just makes math easier. Now, it'd be a good and helpful thing for you to do, perhaps, to plug in the 0, -5, and see what you get. And then also plug in the 6, -6, -5. You should get the same value for a. So I'm going to do the easy one. You can pause it if you want and do the hard one. So I'm going to plug in 0 for x and -5 for y. So -5 equals, we're trying to solve for a. That's why we're doing this. A, 0 plus 3 squared plus 2. So that's 9. 9a plus 2 equals -5. Subtract 2, -7 equals 9a. So a is equal to -7 over 9. Okay, so now I know everything I need. All I needed, I had this equation. I was missing my a, so I said, hey, why don't I use one of these points to plug in for my x and my y, and then I can solve for a. So now that I can do that, I'm going to go ahead and write out my final as y equals -7/9 x plus 3 squared minus 2. All right, let's see if that's what she got. Pull all this work aside. Kind of gets crazy. All right. She got +7/9. It looks like -7/9 here. Maybe you just wrote it down wrong. Okay. I'm gonna say, because I'm looking at this and I think it should have been negative. I think you dropped your negative. All right, so let's look at the standard form. So the standard form just says, this is called the vertex form. The vertex form is great because it allows you to graph it really easily. You can say, if I see this, I know I'm going to go left 3 and down 2. And it's got a negative sign, so I know it's going to be a downward facing parabola. So, I know you have a graph up there, but I'm just saying, if you didn't have a graph up there, I could tell you that this is left 3 from that right there, down 2. That's the vertex. And then I could also tell you that it's going to go down because my a value is negative. So it would look something like this. Oops. And you could plug in some points and get some extra. I'm just saying, we call this the vertex form because it gives us the vertex right there. It's a great form to have. It's important to know. But sometimes we want the standard form. Use the standard form more when you're doing quadratic equation. So you just take your vertex form and you follow the steps. So first you square this guy. So x plus 3 squared is x plus 3 times x plus 3. So x times x times 3, 3 times x. So that's x squared. I'm going to move fast because these videos get long and YouTube doesn't like for me to make long videos. X squared plus 6x plus 9. Okay, so that was that. Now I still have to multiply that times -7/9. And then I still have that minus 2 I didn't do. So that's -7/9 x squared. I'm distributing right now. I'm distributing -7/9 to this, to this, to this. Let's see, -7/9 times 6. Man, you might want a calculator. I don't know. 3 and 3 is 2 and 3. So -14/3, I think, is right. So -14/3 x. And then that'll be -7, and then we have -2. So that makes, for a final answer, -7 minus 2 is -11. So sorry, I know I kind of went fast on that. You'll probably have to do that. That's a pretty hard fraction. You'll have to do that multiplication, maybe on your calculator, or maybe you can spend some time doing that. But that's all I did, is do that multiplication. I'm hoping that 14/3 is right because I did that in my head. All right, and so that's your standard form. So I don't think you have to do this one on the calculator. If you look and see, like, here's an XY plane. If you just try to graph these, just a rough sketch. So I'll say, like, this is 10, this is 20, this is 30, -1, -2, -3, -4, +1, +2, +3, +4. Okay. So -2, 20, or I'm sorry, -2, 31 is way up here. That's -2, 31. -1, 20, that's here. 0, 11 is here. 1, 4 is about here. 2, -1 is here. All right, you could keep graphing. 3, -4 is here. 4, -5 is here. I'm just guessing here. But anyways, here's your graph, something like this. Now, the question is saying, based on the table, solution to the equation, f of x is equal to 0. Remember that f of x, that's the same thing as saying y. It's asking you, where is y equal to 0? Where is y equal to 0? Well, y is equal to 0 right here. Right here, to be precise. And that happened between 1 and 2. Because if you look at where y is 0, well, here's where y is 11. Here's where y is 4. And then here's where y is -1. So it looks like you put this little spot right here, and that's because y is 0 somewhere between these two things. Somewhere between these two things, right? It goes from 4 to 3 to 2 to 1 to 0, then it hits -1. So 0 happens between here. So the x values that led to that are 1 and 2. Okay, so you're looking for where it went from positive to negative, because then you had to have passed 0.